Let's start with the fifth technique of CBM, which is electrical signature analysis, ESA. ESA is a non-intrusive CBM method that determines the state of motor and driven equipment by analyzing the electrical behavior of the motor, namely the three-phase current and the voltage forms as well. ESA reads what the machine tells you through its power lines, in contrast to the vibration and oil analysis. Here, as per the ISO 20958, it is dedicated that ESA standard for three-phase induction motor, and it explains the techniques like signature analysis and the cautions for VFDs as well. And according to the ISO 17359, which gives the general CBM program framework where we need to follow around the electrical signature analysis. If we see a real world scenario in a cement plant where we can't stop a 4 kilowatt ID fan motor to install the sensor, then we use a clamp on CT at the MCC feeds line current to a portable analyzer. There then the spectrum shows the rotor fault side bands. Then the maintenance plans are controlled outside instead of risking a trip as well. So let's move to and see and discuss like why ESA electrical signature matters in business value wise. First thing, it's a non-instructive and a safe method. Clamp at the MCC, like no open bearing housing or coupling guards can be done. And also the second one is that it covers both electrical and mechanical faults as well, rotor bars, stator faults and bearings as well, misalignments, and even the load issues which show up in the electrical signature process as well. And it works where vibration is hard, like inaccessible or in any harsh locations as well, like submerged pumps or where you already have the current transformers as well. For example, if we see in a chilled water plant with submerged pumps that runs ESA remotely from the switchgear. So a raising bearing related modulation on the current prompts a seal and a bearing replacement should be done during the scheduled chiller shutdown. So there will be no lost cooling as well. And we'll see the core methods. So first thing is the motor current signature analysis, MCSA. A predictive maintenance method called motor current signature analysis is used to evaluate the condition of electric motors. And these motor current signature analysis can identify the anomalies including the mechanical problems, bearing wear, and also the insulation deterioration by examining the electrical current waveforms and also by enabling early identification of possible problems, and prompt maintenance actions is also done. This non-instructive technique helps us to avoid any unplanned downtime and also the expensive repairs as well. Coming to the second one, which is voltage signature analysis, very useful for supply problems and to correlate with the current, that is the power quality impact. Although the signal is obtained from the motor's voltage source, the voltage signature analysis is quite similar to the motor current signature analysis. In this case of motors, it can be used for analyzing the current signature, examining stator electrical imbalance, and identifying their problems caused by motor powers. The analysis of the manufacturing unit is where this method is the most frequently applied. And the next method is instantaneous power or power demodulation, that IPSA. This power demodulate instantaneous for the rotor faults is used. Any robust under very load that is used in protection relays as well. And it also tells you the broken rotor bars as well, and the power spectrum shows the components of the 2F side bars around their frequency, like electromagnetic torque pulsation as well, and also like a gear faults, peaks at the gear mesh order and side bands as well. And it also tells you about the resonance and misalignment where and also the direct window into the mechanical health via electrical signature as well. And the next one we'll see is the flux or air gap analysis, where it targets eccentricity and also the magnetic asymmetrics where flux sensing is available. Like it measures the air gap and magnetic flux, end winding leakage flux with a search coil or flux probe placed near the stator. slot at the end winding window, because it is directly sensing the electromagnetic field, and also flux analysis is less sensitivity to the supply distortion, and also the highlights rotor and air gap anomalies are cleanly visible. If you see in a steel mill alternates between light and heavy slab loads, currently only FFT gives the mixed results. Switching to the power based demodulation in the relay yields a consistent detection of developing the rotor issues as well. So as we see, like MCSA, which is motor current signature analysis, is your workshop, and the VSA tells you when the supply is the culprit, and IPSA, which is instant power demodulation as well, makes mechanical torque problems obvious, and the flux is the gold standard where you can get the near the end of the winding. Like, use these two methods, minimum or critical assets, and trend the futures with dB or percentage slip, or that shows ESA moves from snapshots to the predictive decisions as well.